Great. I think we can start. We are enough people for today. I would like to welcome everybody to this hands-on workshop. This is the second part that we're doing in collaboration with the Frankfurt Data Science and the Smart Contract Frankfurt meetup. The first part was mostly going through theory, showing what Daml is capable of, and explaining great use case by other meetup partners. Today, we will have a little bit different workshop. Actually, it's a more hands-on workshop. I'm Francesco, part of the Daml community team. We will have Manish introducing quickly Daml, and then we have Levi going through a hands-on build from scratch demo that we will quickly go through. So I just wanna say this is a great opportunity for everybody to ask questions all the time. This is just not a webinar. The idea is that we're doing a Q&A session, and please jump in if you have any questions. Quickly stating the agenda here, Manish will go through the problem, how the enterprise silos are looking today, and then Levi will take over explaining how this example will look like in reality and build it from scratch in front of your eyes. So great. I will give you the word, Manish, and go for it.
What we are going to be talking about today is also how do we solve that same problem within the enterprise. So, any business process within the enterprise is composed of multiple applications. Each one of them does one step of the business process. And typically what happens is these applications are in different hierarchies, in different departments. They use different technologies, different stuff. And that's why what happens is these applications often have their own vertically integrated, sort of a stack, so there's an application, they have their own database, there's another application, it has its own database, and so on. And then each of these applications will obviously send data to each other in order to, get at the same state of the business process. And we'll show you an example in the next slide, actually. So if you think about a credit card process, and this is also the example that Levi is going to cover during the hands-on demo. But you think about, you're applying for a credit card to a company, say a credit card company. There is a new account system where your application goes in. Then the application is sent to the underwriting system. They typically have their own databases, for example. They'll look at your data, they'll run some credit checks and all of that stuff. And then they'll pass the data back to the new account system and your card is approved. When the card is approved, obviously that information that you as a customer, what is the type of the card, what is the credit limit, etc., is sent to many different systems. So, and typically, multiple applications manage all this. So there's an e-statementing system, there's a fraud detection system, which is looking at your transactions and making decisions. There is a payment system and all that. And the problem that we are seeing with that structure, traditional structure, is that obviously for AI and business intelligence folks, if you have to do analytics and business intelligence on this entire business process, there is a process of aggregating the data from all of these different sources, making sure that the data is reconciled and the data from one system does not contradict with the data from the other system. For example, you might have an active card in one system and expired credit card in another system. And then somehow somebody has to look at what is the real state of the business process and clean up that data before they can feed it for analytics. Another big problem, sorry, Francesco, if you go back, right? Another big problem is on latencies. So when you make a payment, almost all of us have seen, we make a payment and your payment is not available online immediately. It takes 4 hours, maybe 6 hours, maybe sometimes the next day for your payment to show up online. And that's the latency in the whole business process, because your payment system has to send the information to another system in order for that system to pick up and show it on the website. So we've got this, typical issue of checks and balances, data reconciliation, and latencies throughout the enterprise landscape. And on the next slide, you'll see that that is exactly the problem that a lot of us face. So whenever you need to do analytics, you spend a lot of time aggregating, reconciling information. And statistics show that almost 40 to 60% of your data management effort is spent in these first two phases. Only then you get to enriching the data and then analyzing the data and running algorithms and improving the business performance. And that is the problem that we want to show how we can solve. So on the next slide, um, you'll see that we are not changing these applications. We are not saying that you should redo all of these applications using a different technology. What we are saying is that there is a new way to connect all these applications using a smart contract based multi-party workflow, which means that each of these applications now has has a view of the same state of the business process at any point in time. A payment comes in, the payment is applied to the credit card, and all of the other systems automatically get to see the same information based on privacy and confidentiality. Of course, you may not want one system to see what's happening in the other system. That can easily be controlled, but still, there is no latency in the system anymore. And what happens is you can now take this smart contract store that you have, and you can generate business intelligence and AI and all of the other things based on this smart contract store, instead of having to run the traditional ETL, aggregate all the data, make sure the data is clean, scrub the data, and then load it into your into your data warehouse. So we'll show you how you can get rid of some of those inefficiencies. And obviously, like with any technology, this is a roadmap. So it's not that overnight it's going to change, but hopefully a lot of many of you are architects. We were just speaking to an architect, enterprise architect. Some of you are blockchain developers, some of you are innovating with new products, and you'll see how this kind of an approach can become a part of your enterprise roadmap. So there's a new approach to manage the data, manage all the business processes. So this is Daml. So this is the demo that we'll be showing you today. Daml is a smart contract, open source smart contract language. And there are just a couple of properties I want to highlight before I hand it over to Levi. As you can see, your applications, the ones on the green, are those business applications that we saw on the previous slide. What will happen is when we create this multi-party workflow using Daml, one of the big benefits of using Daml versus any other technology here is that it is completely portable. So you see a list of all of these blockchain platforms at the bottom. So VMware's blockchain platform, Hyperledger Fabric, Sawtooth, Besu, Corda, and all of those. Your Daml application is going to run seamlessly. Once written, it's going to run seamlessly across any of these blockchain platforms. So you don't have to modify your code, and you don't have to select the blockchain platform before you start your project. Similarly, the second row deals with databases. So it shows you that Daml also runs on databases. So the example that we saw before, the credit card process within a company, you don't really need a blockchain within an enterprise. You can just run your business processes on a database, and then Daml allows you to do that without trying to deploy a blockchain whenever you have to write a smart contract based workflow. The next important thing that I wanted to talk to you about is interoperability. So you see that Daml connect arrow between the left and the right sides. What it means is that the credit card process that we just saw can be run on a database on the right hand side, and then when this company wants to connect to an external blockchain network, say between a couple of different credit reporting agencies, or between a different collections company, or any other enterprises that it might want to connect to, that is probably going to be done on a blockchain. And what Daml Connect allows you to do is for the internal business process to interoperate atomically and consistently with the blockchain network that you're setting up outside. So that's a tremendous, very tremendous, significant improvement over the interoperability, paradigm that we've been discussing, because it allows your business process to seamlessly move from outside the enterprise to inside the enterprise and back. So I think that's the second most important thing that I want to talk to you about. So now I think let's get into the demo. Levi, if you have anything to add about Daml, and then let's get into your example.
Okay, yeah, just a couple of things on this slide, Manish. I think kind of one of the most important properties of Daml is it was built fit for purpose, particularly to express multi-party workflows and business logic. So you'll never see sort of that systems level code, which is usually undifferentiating to your business. You'll never see that sort of systems level code intermingled with the business logic. And what this allows you to do is basically focus on what you think your value add is in your application. In today's demo, what we'll actually be doing is we'll be writing Daml code for the Daml runtime. So that's that thing in the middle. And what that does is it specifies sort of the rules of the system, the rules of the application process. And the neat thing is that this will run exactly the same way, no matter what persistence layer or the thing, one of those choices on the bottom you pick. And it also helps you create an upward facing API where it says Daml Ledger API. That's usually traditionally something like a Node.js backend to your front end. It'll also automatically create that so you don't have to. And you can just focus on, when you're writing your application, you focus on the React front end or your Java integration or anything like that. And there's already an API for you that is 100% coherent with the business logic that you've put together. I think that's all I wanted to say on the slide. I think if you're okay to do so, I will share my screen and get into the demo.
For sure.
All right. So what I will, and maybe is it a good time to pause for questions here, or should we just jump right in here?
Yeah, I mean, yeah, let's keep it open for questions. Anybody, if you have any questions, definitely post them in the chat or in the Q&A, and then we'll take them as we go along. So let's try to keep it interactive. Okay.
All right. So let me go ahead and share my screen here. And actually, all of the code that I'm writing today is going to be available publicly on a public repo here, and we'll share these links out at the end there. But I would suggest if you're going to start developing with Daml, kind of your first place that you should go, how to install the thing, what are all these different Daml concepts, go to docs.daml.com, and you can go ahead and get into the get started button for installation instructions. There is a reference API there. It tells you how to build applications. It's a really good, and I would say well-written and mature bit of documentation to not only get you started, but also to keep you in production and keep you productive for a long time. Okay, so with that out of the way, I will jump into the black screen of death. This is where I'll start my application. So as Manish noted, what we'll write out today is a business process where a consumer can go ahead and apply for a credit card, and in the back end of that, an underwriter can approve or decline that credit card. So nothing too crazy, but you'll see that I'm not going to spend a whole lot of time on the system's logic at all. It's all going to be hopefully something that is comprehensible, not just to a developer, but also to like a business analyst that you might be working alongside. All right, so to that end, I'm going to start a new project called, let's say, CC demo. And what this does is it evokes the Daml SDK, that's our software development kit, which is completely free to use. And it creates a new project called CC demo. There we go. And what this does is it creates a new Daml project for us in a directory called CC demo, which I will now open in Visual Studio Code. That skeleton template that it's referring to basically put something into your project so that you don't start from a blank sheet of paper, but which demonstrates some of the sort of key features within Daml. You can go ahead and drill down into the Daml directory, see main.daml, and it's a tiny smart contract, and along with some test scripts here. So what Visual Studio and the plugin that we wrote for Daml gives us, and once again, this is all open source and free, is the usual syntax highlighting, code completion, all of that good stuff, as well as a testing framework that allows us to do test-driven development. So what happens is you simulate a number of scenarios, a number of interactions between different participants, and then you can see exactly what happened on the right-hand side within your ledger, including, you know, the entire transaction stream, what data was entered, who did it, etc. But I won't go over this just now. I think it's instructive to look at, and if you get a chance, do look at it. But I will do what I will do now is actually start from a blank sheet of paper to create my credit card module. So I create a new Daml module. So to that end, I will say module credit card. And this makes the remainder of the file the specification for my credit card module. And this makes it importable, it makes it packageable, and so forth. Okay, so most of the time when I'm writing Daml, I'm creating these things called templates, which define the behavior and the rights and obligations associated, the behavior and the data and the rights and obligations associated with the objects or smart contracts on my ledger. So I'm going to define this a credit card type of smart contract, which I'm going to spell out all of the details, what goes into the credit card, and also who gets to do what and when. So I'll simply fill in the data details here. So what goes into a credit card? Well, there's an owner. This is the person who's owning it. There is an underwriter. That is the person who needed to have approved the loan, and it's also the backer of the credit card here. It's the person that's actually needs to pay the institutions that you pay with on credit. Let's give it a type, which for now is a bit of text, but I'll change that. So this is going to be like, is it the rewards program? Is it the flights? Are you going for points? Is it the one that lets you into the airline lounge, etc.? Then there is the credit limit on it, which is going to be a decimal. Let's give it the name on the credit card, which is a bit of text. There is also going to be the expiry, which is a date. And I will go back into what some of these types mean in a little bit. So don't worry, there's just a couple more fields here. There's going to be the credit card number, which is going to be an integer. So this is literally the 16-digit code which goes on the front. And if I'm just going to check my notes, I believe, oh, one more thing, the currency. What currency is this thing issued in? And it looks like I have everything except the balance. Okay, so, and this is actually all I need to specify a template. All I need to specify the behavior of a smart contract. It's very minimal, so we'll enrich it. We'll get to how to add a lot more logic to it. But let me just pause here and show you what each of the different sections mean. So as you can see, you know, lines 5 through 13 are the names of fields which are going to go into the contract. And the thing after the colon is some sort of type. So you have party, text, decimal, date, integer, all sorts of other good things. And in fact, so text, decimal, date, and int are kind of obvious. Party is a little bit less obvious, but and I'll describe those what they mean in a minute. But the important thing about the sort of the more vanilla types is that you can create your own in case you want sort of much richer data. So we have examples where an individual smart contract represents, you know, hundreds of potential fields. One of the use cases that we work on has to do with specifying interest rate swaps, and we include the entire, you know, flow schedule on a single on a single contract, and that's potentially hundreds of fields. But I don't spell out 100 fields over here. I create sort of more abstract data types that represent what I want. In this case, what I'm going to do is I'm going to create a rewards type, which is either going to be point, it's going to be cash back, or it's going to focus on the perks. And I'm going to say that it's deriving those two classes. And all that means is that this type, this rewards type, can be either points, it can either be cashback, it can either be perks, and equality and serialization, that's the show part, should be derived in the most natural way. So I'm not going to need to define those two functions here. So I don't need to define equality and serialization at all. And what I will do is I will set the reward type over here to use my own type. So pretty much, once you define your own data type, it becomes a first class type within the system. And Daml actually has a very rich type system where you can create variants, you can nest these things into each other, you can define all sorts of logic on top of that. Now, one type I didn't get into much is the party type. And this is kind of the sort of secret sauce of Daml in a way. You can think about it as abstracting away all of the details of the participant who is actually able to act on my ledger. So in kind of a typical blockchain fashion, this would encapsulate all of the cryptography that would go in to make sure that the person who's acting is actually the person that they're acting as. But it's completely abstracted away from me. You'll never see cryptography within Daml because we rely on the underlying persistence layer to take care of that. And what this allows me to do is it allows me to say who needs to be disclosed, what contract at what time. It allows me to say who can do things at certain times. It also specifies who must do things at certain times. And the way I do that, the way I express those concepts, in one part, it's going to be the signatory keyword. And when I say that the underwriter and the owner are a signatory, this has some very important implications within my application. So firstly, it indicates that in order for a credit card object to exist, both the underwriter and the owner must have consented at some point in the past. There's no way to create a credit card without the consent of the underwriter and without the consent of the owner. That's one implication. The other implication is that you assume that the underwriter and the owner, once they've signed up to the credit card, they understand all of the implications that go into all of the future implications that go into being part of this contract. Okay, and naturally, when since the underwriter and the owner are signatories on this thing, they can't, and they're assumed to be distinct actors. And I can actually ensure that the underwriter is not the owner. It must be that they have to grant their consent at separate times. This is intended to be a multi-party system, and you assume that there's no way that two parties, you can ensure that two parties can sign off on the same thing at the same time. So what I have to do is I have to create a way for both the underwriter and the owner to sign off on the credit card beforehand, a priori. The way I will do that, and usually what this requires you to do is think about in the real world, like, all right, how is it that my signature and the bank's signature, the underwriter's signature, ends up on the credit card? And it's usually because you put in an application and then they approve it. So that's the process that we're going to model out next. So what I will do is I will create a credit card application contract, which has some of the fields filled in from before. So there's an owner, that's going to be you. Here's the underwriter. This is the party who you're asking. This is the type of card that you want. You're not going to set a limit. That's going to be set by the underwriter. Here is your name so that they can do a credit check on you. Let's see, you don't determine the number of the credit card. That's going to be determined by the bank. And you tell them what your what currency you want the credit card in. And we're going to say here the only signatory actually is just the owner. Why are they the only signatory? Is because they're the ones who are backing their own credit card application. They're the ones that are verifying that the name that they put in is accurate. They're the one who are going to oblige all of the future consequences of this contract. Well, so what are the future consequences of this contract? And I'm gonna spell that out right now. Kind of the flip side of the signatory keyword is a controller keyword. You can think of signatories as being obliged to do something, like you have to do something. The opposite of that is that you can do something. So I'm going to say that the underwriter, in response to your credit card application, they're able to issue the credit card. Yeah.
So quick question, Levi, after you're done, if you can briefly touch upon the authorization model. I think the question that came up is, how do you ensure party properties like the cryptographic key, and how do you, why don't you check it in your code every time?
Okay.
So if you can just cover the authorization model a little bit.
I'll touch on that. I'll spell out this choice here.
Yeah.
And I think I'll go over that.
Yeah.
Okay. So I'm going to spell out this choice here. Like, I'm giving now the right to the underwriter to be able to actually issue the credit card in response to the application. And what they will do is they will specify the limit, which is the decimal from above. They will specify the expiry. This is basically all of the fields that all of the data that the bank is setting when they issue that credit card. The balance is going to be 0, and they will specify the number. And what this will do is this will create the credit card application with a 0 balance. You don't want to start with a balance on your credit card, and all of the fields. This little 2 dots here means that I'm using all of the fields which are in scope for me to create the credit card. So basically, I'm copying over all of the data, and thus, this is what the meaning of the issue credit card choice is. It basically says, tear up the application. So I implicitly get rid of the application here. And I create the credit card with a 0 balance, with the same fields as above. And by the way, this archival and the creation all happen atomically. So if for whatever reason the archival fails or the creation fails, then the other event in this stream does not happen. So on the authorization model, so I'm saying a lot of things about who can do things, who must do things, who can see things, etc. But like, how does that physically work, right? And the answer to that is that it's going to work completely differently depending on the persistence layer that you've picked. So it'll physically work differently, but logically it will work exactly the same way. So once, let's say if you're using Postgres as your underlying persistence layer, then, well, you know, the encryption scheme you might use is as simple as a username and password. If you're running the thing, let's say on VMware blockchain, then there is an entire you know, public secret encryption scheme that is happening in the background. But the Daml model, in a way, doesn't care about it. It assumes already that the participants which are using the system have identified themselves correctly to the network. So they assume that when they issue a command from let's say their front end, that they usually pass along some sort of a token like a JWT or let's say a public key, and that public key correctly identifies the literal agent as a valid or invalid participant. So we rely on the underlying persistence layer for the identity. But once the identity of the agent has been established, then the Daml models take over. In a way, all of the ledgers that Manish showed on that slide, they make their own assumptions about how identity is verified. We do not add or remove anything from that. We simply make use of the fact that an identity has been established. And you'll see actually when we deploy this thing onto our own cloud hosted solution, that the way we identify is we basically, on that one, it's like auth 0, where you pass along a JWT anytime you try to do something on the ledger. But that's just an example. The underlying persistence layer will ensure that differently. All we care about when we're writing sort of the business logic is who can do what at what time and who gets to see things. I didn't mention that, but the only way anybody has access to any of the contracts is if there's some sort of a stakeholder on it. And we define stakeholdership, you know, kind of very precisely. It means you're either a signatory or a controller. There's a third option called an observer. I won't get into that now, but it's very obvious just by looking at a template who's going to be able to see it. You can kind of think about that type of disclosure as row level permissions on a database. So you can think of like, okay, who gets to see this credit card? Well, I see that only the underwriter and the owner are signatories. So the credit card is going to be disclosed to the underwriter and the owner. A different contract with a different owner is going to be only disclosed to that owner. It's not going to be disclosed to anybody else. Same thing on the credit card application. The only two stakeholders on this thing are the owner and the underwriter. So they're the only two people who is going to be able to see it.
Yeah, this also, so just wanted to say, Levi, for the audience, I think this also means that privacy can be configured at a much granular level within your organization. So a smart contract being operated on doesn't mean that everybody in the chain of that smart contract can get to see it. You can define it at every level who can get to see it.
Yep. Particularly within an enterprise, that means you might have different permissions for the individual people versus the desks that they report to or the departments that they work in. Supervisors versus not supervisors, senior people versus non-senior people. So you can make those really granular disclosure, but it's more than disclosure. It's also who gets to act. Like for instance, in this credit application, choice, and these things are called choices, by the way, only the underwriter is able to issue the credit card then. A Daml transaction is considered invalid if, well, let's say it's in the wrong format or something like that, or you didn't specify an argument. It's also considered invalid if the person didn't have the right to do what they wanted to do. So in this case, let's say the underwriter, the owner tries to issue themselves the credit card, or a third party tries to interact with this contract. And then there's a sort of third guarantee that we also make is that a contract is never going to be archived twice. So there's also sequencing logic that that we ensure, so that yeah, it protects us against double spends and things like that. So Daml will check for that. Okay, so I think I'll also pause there now for questions. So I talked about the significance of the signatory and the controller keywords. And like I said, it's kind of those elements are kind of the secret sauce of Daml. So I want to pause there and make sure that everybody understands that before I move on to the next thing. So any questions so far on those in particular? Is there any questions, or should I just move on, Manish or Francesca?
So far, basically, we've allowed the owner, which is basically the prospective customer, to create a credit card application.
Yep. Yeah, that's right.
And then we've given the ability for the underwriter to approve and issue the credit card. That's what we've done so far, right? Okay.
Pretty much. Yeah. So that's all we've done. I will enrich this ever so slightly. I'm going to put in the opportunity for the underwriter to also decline your application, so that along with a reason. So I will say, you can decline the application. This will result in a third type of contract that I haven't spelled out called a declined application. And hopefully they give you a reason why they declined it, and they can give you maybe another card to try for next time. And I will say create the declined application, which I haven't spelled out yet. There we go. What I will do is I will say, okay, what is this declined application? It's something which is basically undersigned by the credit card company, saying like, this is why you didn't get your application. So the we have the owner, we have the underwriter as before. We're going to have the suggested CC type. There's the original credit card type that you went for. Here's your name and the currency that you wanted. And this thing is, in this case, is only signed off by the, actually, let's make the owner and the underwriter sign off on it. And what I'm going to let you do is, as the owner, you can reapply basically. So you can say request new card, which will generate the credit card application from this. So from your declined credit card application, you can basically create a new fresh application potentially with a new card. And all I'll do is I'll say create the credit card application with the CC type equal to the suggested CC type. All right. So what field am I missing here?
I think the application spelling is incorrect. I think in the online number 50.
Yes, you're right. You're right. And I forgot to put the reason in here that you need to be able to see. Decline application. All right, that's better. So I've added this possibility now for the underwriter to decline your application. They need to give a reason, and they need to suggest to you a different type of card. you didn't specify for the perks one, but maybe you specify for the cashback one, or it's actually probably the other way around, because you need to pay for the perks usually.
So two quick observations, Levi, here. So one is, of course, looking at the business process that we had, the new accounts application, the underwriter, and so on. We are not saying that those applications need to go away. We are just taking the core logic, which should be common across these entities, and putting that into Daml. And then this will still be invoked from the existing front ends that the enterprise might have, right?
Yeah.
You show that. The second thing I wanted to, you use the observer keyword in the first contract on top, observer underwriter, right? No.
No, there's no observers. I mentioned it, that's a possibility, yeah. But I did not include it.
Okay.
Question. I see a question from Emmanuel that is asking, where is the request new card defined? Are we defining the new
yep,
card
right here.
requesting? Oh yeah, there you are.
So you can go from your declined application, you can request your new card, and that's going to create a new credit card application from that rejection. Okay.
Yeah, and I think these, I think Emmanuel might be talking about request new card. It doesn't have to be predefined, Emmanuel, because request new card is a choice or an ability or a capability or a right of the owner, and that can just be defined at runtime. And it can be any name. So request new card
it's not at runtime. Super important.
Yeah.
Not at runtime.
No. You can define it. You can make it whatever you want. It doesn't need to be predefined.
That's right. That's a good point. All of the like, there's not that many keywords in Daml actually. You've got template, with, where, signatory, controller, can, but request new card, decline, issue credit card, the names of the fields, all of that is up to you. And we follow the convention usually that the names of templates ought to be nouns. They're going to represent objects or contracts in your ledger. The choices ought to be verbs, so these are things that you're doing on the ledger. Yeah. So yeah, all of the stuff in light blue is either going to be something like integer, which is a native type, or or something I define, like the case of rewards. That is, we defined what a reward is up there. So anything else is really up to you to spell out in the way you like. And that's, I think that's kind of the cool thing, is that so like request new card, there's nothing else to do to create the credit card application. You just say create the credit card application. With one change, the credit card type should be the suggestion rather than what's there before. And hopefully I find it legible, but hopefully you find it legible, that there's nothing in here about cryptography, serializing the thing, integration, or anything like that. And the neat thing is that this also supplies an API to your front end or to your own integrations. And if there's no objections, I'll get into that part now. Okay. So one thing is, once I've built my Daml model, and there's a whole testing framework around this. So probably the next thing I would do is test it out and create scenarios and test those out. But just in the interest of time, what I will do is basically show you how to create the front end for this. So this supplies the business logic. Now we need to write a front end that says, okay, where do the buttons go to request a new card and all of that good stuff. So Daml actually gives us, first of all, the SDK gives you a compiler, so that's good. So when I say Daml build, it creates what we call a DAR file, which is a bit of bytecode that represents the business logic. Okay, and that bytecode is going to run in the runtime, very analogous to Java and running on a JVM. Is that you compile down to bytecode and then that thing runs in a runtime. So that's what this DAR file does. But what I can do from that is I can code generate into a directory called daml.js. Oh, I forgot to include. So now I'm going to code generate JavaScript, JS, into a directory called daml.js based on the DAR file that I just created. So note that the DAR file got created in here. So what I will say is I'll generate JavaScript based on that DAR file. There we go. And if it all goes well, it creates a number of JavaScript types. Now, so here it is. There it is back in Visual Studio Code, all of that JavaScript. You don't need to be able to read these template declarations. What's important here is that automatically, based on the two modules I have, main and credit card, the SDK generated, I think this is the right one. Here we go. Generated a number of types for me based on my Daml module. So you've got declined application, request new card. All of the verbs and nouns that I saw from before are declared now as Daml types. And what this allows me to do, and I pre-cooked this, I'm not going to do this on the spot for you here. What this allows me to do is I wrote a React front end using those libraries here. So here you can tell it's React because it's super verbose, but you can see that there's some HTML looking things in here. But what I have done is I have imported from those code generated libraries the names of the types that I've been using. So what this allows me to do is it allows me to do particularly these 3 lines, which says connect to the ledger and fetch me all the credit card application and declined application contracts that I'm entitled to once I've been authenticated. And then all I do actually within the HTML is that I just loop through all of the different contracts and show you their their contents. Another thing I do is there's a button in here where on a declined application I can decline or I can request a new contract, and this just request card function is a little bit interesting because look at what we're doing here. We're simply saying exercise that choice. There's no parameters for it, but basically exercise the request new card choice on the contract that whose row we're clicking on. The point is this ledger object is something that we supply. It's part of the React library that we provide for you, so that you don't have to serialize and deserialize JavaScript. You don't have to write an API layer to interact with your persistence layer. That's done for you. And to that end, what I will now do, and this code generation, by the way, is available in different languages. So JavaScript, Scala, and Java proper. So and you can use those objects to within your application.
Just one quick note for the audience. Obviously, the front end, the React app is talking to the ledger through REST APIs, and therefore they're able to exercise this function that we have defined, requesting new card, and obviously fetching the contracts from the ledger as well. All of that is automatically exposed as REST APIs by the Daml runtime, so you don't have to actually code those APIs by hand. So that's not
yeah. And very importantly, you can interact with the ledger just via pure REST. What these React libraries do on top is that it abstracts the REST and the WebSocket API so that you're manipulating what looks like native TypeScript and JavaScript rather than having to, you know, create post calls and all of that stuff. So it even helps you there so that you don't have to hand roll your REST calls. Okay, so with that, so I wrote my business logic, I wrote a front end for it. So let's actually deploy this thing into production. And the way I've done that is we've already compiled the DAR file. The next step I would have to do is I would have to compile the React into a simple static repository. But that takes a minute, and I've already done it, so I'll just go ahead and deploy it. So I'm going to choose to deploy it on our cloud-hosted platform, which is takes care a lot like spinning up a ledger for me. So it's very handy, kind of for testing, and also for actually for a lot of applications, you can go right into production using Project Daml. And you can see I've got multiple projects happening, multiple projects going on at once. Including I've already deployed a ledger for myself. What I will do is I'll start one from scratch. Yep. So I'm deploying a ledger called demo. And then what that will do is it actually spins up a container somewhere in the cloud, hosting all of that entire stack that we were looking at as a last slide before we went into the live coding. So this takes care of the persistence for you, and it also takes care of the front end for you.
One quick question, Levi, that came up before we get into this. How do the signatories become controllers? I think that's a question. As a developer, how do we understand how the signatories become controllers? Okay,
good question. In fact, it sort of happens the other way. You can think of controllers. You can let me go back to the Daml code, and thank you for asking that question. It gives me 2 or 3 minutes before my ledger starts up. In fact, it sort of happens the other way. Let me see. So here on the credit card application, only the owner is a signatory. But when the underwriter, he's a controller. Note he doesn't have any obligations on the credit card application, but he has a right on it. So what happens is controllers can become signatories, right? This is what this is expressing, is how does the underwriter go from having a right on something to being a signatory on something? And that is always the order, because you should never become obligeable in something without your consent. You should never be obligeable in a contract unless you did something to get into that contract, either by creating the contract or exercising some sort of choice, exercising agency to get into that contract. So in fact, it actually kind of goes the other way. You go from being a controller to being a signatory. You can also grant rights to people who have undersigned on things. For instance, on the declined application, both the owner and the underwriter are already signatories, and we grant the owner some rights. But actually, we could have taken out the owner as a signatory here, and by requesting a new card, he would have become, or she would have become, a signatory on the credit card application. So it always goes in that direction. You have the right to do something before you are obliged to do something. Okay.
Yeah, thank you.
Yep. All right, so my ledger has been spun up. And all I need to do right now is I need to upload the DAR file that I've created. And it's the pre-cooked one because I didn't compile the zip file for the thing that we just did, but the code is identical. So I upload the rules of the game, and I'm going to go ahead and upload the front end for it. And we saw the front end more or less. And like I said, all of this is available in a public GitHub repo, so you can go ahead and look at it yourself. So I will deploy the DAR. And once that's done, I will deploy the front end for it. And this is actually Daml gives me the feature that it actually claims this subdomain for me, which is now actually in production here. And I will go ahead, and there's just one party on this ledger for now, but I'm going to invite all of you to participate if you like. And so I'll post this subdomain in the chat.
It's basically idea to live production in 40 minutes.
Indeed. So let me chat this out to all of the participants, panelists and attendees. So go to that. Did I not copy it? There we go. Go to this website, and you also need another crucial bit of data, which is the My Ledger party. I am the underwriter on this network, so if you want a credit card, you need to ask that participant there, and that's me. So what I will do is I will follow my own advice here. I will go to the website here that I indicated, and this is a new domain that it claimed. I will log in as Daml. You may have to create sign up or something like that if you want to log in. Oh, Manish, you don't have to send me your ID actually.
ID, okay. Yeah, I was able to log in, and I'm seeing.
Yeah, maybe.
Can I apply for a credit card here?
Yes.
Yes, you can. So go ahead and.
It's asking for an underwriter. Do I need the party ID?
Yes,
the underwriter is the ledger party I provided, Manish.
Okay, got it.
So the one ending in 80430. So put that as your underwriter. So go ahead, apply for the credit card. And this is the cheesy HTML you saw before. So put exactly that underwriter there. This is Levy here. This is me. I want the cashback one in dollars. I'll say okay. And this creates a new credit. Let me make this bigger. It creates a new credit card application for me that I see the status of. Just imagine if you could actually see your applications in banks as they were being processed. And what this shows me, oh, you submitted it? Okay, good. So, and I'm going to go back right now into Project Daml. Here we go. And if all goes well, yeah, there's two credit card applications, I think one from Manish and one from myself. I'm going to issue both these jokers a credit card. Let's see. That's going to be the last four digits of the credit card. 10,000, and I'll say submit. By the way, all of these UIs for the backend are automatically generated from the Daml that's been uploaded. So you can sort of administer your ledger yourself this way without having to write a front end for it. Did I say issue? Oh yeah, I see what I did. And it should expire, I don't know, in a year or something with a $10,000 limit. Go. There we go. So that should have issued a credit card to myself. which is right here. So there's an approved credit card. Oops. And I will decline Manisha's one because why not? Pause. And I suggest that he try for the cashback one instead. There we go. So now you can see all of the objects that I'm seeing as the administrator for this ledger. Okay, so you got the idea. What Daml hub or project Daml allows me to do is quickly upload my backend, my front end, and it'll automatically take care of the rest. Really, that's all you need to put something into production very quickly. Once again, there's a free version of it as well, so you can play around with it yourself. And I think that's all I wanted to cover, guys. Is there anything else that you think I missed, Francesco and Manish? Or
nope, I think this was really helpful. And obviously, just to reiterate, the code that we just saw, couple of things, right? Obviously, it's focused on the business logic, so you didn't see Levy do anything hardcore technical, like look at identifiers, if this party is authorized, then do that, else decline. All of that stuff is not required in Daml. So it makes it obviously very simple to model your workflow. And you saw that, very quickly you can move from a quick concept in your mind to a quick Daml model deployed live, and you're ready to demo your app. And this same app will obviously run on any of the Daml supported blockchains and databases that you saw on the slide that we showed you. So you can take this same thing, deploy it on Fabric, Sawtooth, Corda, Besu, and it'll run exactly the same way. The only thing that will change, obviously, is how you configure the parties and you create those users on the ledger. I think that's all. Yeah.
Yeah. I think there was a couple of questions on the deployment one, but they were basically answered online. And
yeah. Actually, Levi, there's one more question from Ravi about scalability in Daml. How about scalability in Daml? Can you talk to that a little bit?
Yeah, sure. So a lot of that depends on the ledger choice, but actually a lot of it also doesn't depend on it. The most of the components within the stack that we're looking at are horizontally scalable. This even includes in the case of in the Postgres, for instance, all of the what we call the ledger API, which is kind of the bridge between the Daml runtime and your front end or your application. That bridge is 100% horizontally scalable, except on a single party read, single party commit line, because that needs to actually be sequenced. But that turns out to almost never be a bottleneck for this. So every aspect of the application is 100% scalable. And just to sort of give you an example, the sort of applications we've put into production, for instance, at the ASX, we haven't put that into production, but we will put it into production. You're looking at tens of potentially tens of thousands of transactions per second, and horizontally scalable, lots of different participants doing the trading, etc. So for most applications, there's not going to be a problem with being able to scale this thing.
Yeah, and also there is a video, Francesco, I think we might want to send this link as well in the follow-up. I think there was a recent presentation by Scholl, our CTO, on Daml scalability and how the infrastructure scales, so I think that would be a nice link and video to send to everyone.
Yes, totally.
There's another question from Kwab. This is about, could you walk us through the process of updating the Daml file and deploying again? So how does that work? And the second part of the question is, are these data stores decentralized? So I think we might want to do that second part first, Levi. So data stores, depending on the persistence layer, it'll depend on that, right?
Yeah, pretty much. Even for Postgres, you can choose to basically shard it across multiple nodes if necessary. But for let's say like a blockchain proper, like VMware blockchain, yeah, all of the data stores would be decentralized. And in that one in particular, also Corda and some others, you only get access to the data, like physical access to the data for contracts on which you're a stakeholder. So there's, that's not true for Postgres, obviously, because it's all in one place, but for sort of the proper blockchain implementations, or the blockchain propers, they are, the private stores are segregated.
Yeah.
On the upgrade,
Daml upgrade, yeah.
Yeah. Okay. Yeah. So, actually, maybe there's a good sort of document on this in the documentation. I don't want to walk you through because it's a.
We can cover that on a separate webinar. Actually, that might be good.
Yeah, that might be worth a webinar onto itself. But the idea is no technical migration. Everything happens on Ledger. Version 1 to version 2 of the Daml of your Daml model will coexist for a time on the Ledger, and then there is a sort of an upgrade contract which transforms version 1 into version 2. And depending on the permissions on your contracts, the upgrade contracts might be 100% delegated to one person, or you might need to get sign-offs again from the original signatories. It's actually up to you, and it depends on the business case. The upshot is the upgrades are business upgrades. They're not technical upgrades. In other words, if you change the terms and conditions on your signatories, you want them to make sure they're cool with the new version before you foist the second set of semantics on them. So and you, in other words, you do it with a workflow.
Yeah. Perfect. Yeah, I think those are the questions.
Yeah. Any other question, guys? If not, we can just conclude with some remarks.
So I'll stop sharing them?
Yeah, that was great, Levi. Thank you so much.
Yes, super interesting. Let me just go through. So I just have a quick last slide, but if you guys are still not in the forum, and any question can be really asked there, I can jump in quickly. So we have this forum, and it's basically on discuss.daml.com, and any question that you have, we have multiple per day, and it's quite interesting because all our engineers are up to any question here, and we're also sharing some good news that is happening in the Daml world. That's one thing, and also for the tutorial, especially for the people that are beginning, you can check it out here, the tutorials and guides. But it's quite important that I would like to share here is basically when you don't want to download the SDK, install all dependency, you can just run all those scenarios online. So those are pre-built scenario, and you can click on the getting started. For example, there are multiple scenarios here, but basically everything is done in your browser. So everything that Levi did it today, especially for starting out. Yeah, I totally suggest that you guys are checking this out. And if you have any question or it's not working, just screenshot it in the forum, and we will make sure to answer it.
Just one thing, Francesco. Yes. There was a one of the modules was the upgrade. So to the gentleman who asked the question about the upgrade, there is a pre-cooked example for you for that as well, and it works well.
Yeah, we can definitely also share this link afterwards. Quite easy, and there are actually 3 scenarios in the upgrading one. Quite cool. Yeah, and Levi mentioned already, we have also the GitHub repo that you guys can check it out. And yeah, I don't have anything big right now to say apart thank you very much. And I think we decided at the beginning we could do this 10 minutes some kind of after Zoom in this one, so that if any one of you have any question, we can just make, I think, everybody as a panelist. I don't know how it works, Manish. something like
Yeah,
that.
no, I think we can stop the recording and then we can do that.
Yeah.
So thank you very
Yeah.
much, everyone, for attending. And those of you who have questions can stay on, and then we can take them. Thank you very
Welcome.
much.
Thank you, guys.